back. Basically, these are loads that were simulated. It's three 13-watt light bulbs, a cell phone charger, and a microwave motor. Pretty much cell phone charger is just something that is pretty much crucial because like a few months ago, I say 3 months ago, when the heavy snow, and a lot of people lost power, they lost their ability to communicate as well. When they weren't able to say charge their cell phones, or even like house phone lines now, they run on the power from utility.
This next picture is basically the circuit we have together. The big green mess over there is what their transducers. We actually also have the Hall effect, where when we read the current, we're using the Hall effect, and it goes from about -35 to 35 amps and brings to 10 plus or minus 10 volts. That way we can read it into our acquisition board without damaging the board. Each of the voltage readings can go from about 500 volts down to plus or minus 10. That way we can read anywhere from 120 to 240 volts, depending on what part of the house it is and what appliance you're trying to read the voltage from.
This is pretty much the LabVIEW user interface for the user. On the left side screen are switches that allows them to turn on, say, various loads that they want. And all these graphs, different power statistics. They pretty much show, like, say, the battery voltage, utility voltage, basically the inverter, what voltage is supplying, the current coming out of the solar panel, the batteries current, and basically the current coming out of the inverter. This is important because it tells you pretty much how long that the system is going to last. And this next part is the block diagram of our LabVIEW program. This allows us to do switching on and off of the loads. By the use of BJTs and FETs, we just pretty much, depending on this first half is the data acquisition. The small box here is data acquisition. Then it takes the 6 different inputs, does some comparison, and then sends out digital outputs, basically depending upon what say switches the user has pressed. The RMS voltage, say if the utility is no longer on, then it'll automatically switch to our system. Or say if the user doesn't have load 1, the switch press, load 1 won't be on. And on the other side, pretty much it takes these different arrays. The arrays are basically the user's conditions, and then outputs to say various switches that we have set up. And pretty much we designed the BJT circuit to trigger off of 5 volts. It pretty much just, we designed the driver circuit to drive the correct current, given the 5-volt pulse.
Basically, some of the challenges we've come across is basically triggering the system. It has to be able to run under analog circumstances. We're basically using a digital pulse sending it out to MOSFETs to drive an analog signal or AC signal. Another thing is the solar panel has variable power depending on what time of day it is and what the conditions of the weather are like. So we have to take that into effect in our calculations. For these two, one of the bigger challenges was basically we've never used LabVIEW before for data acquisition, so we basically had to learn LabVIEW to put together our project. Another challenge is definitely we've learned about ordering parts and how long the process is and getting parts through. It took a lot longer than we anticipated. And another thing is with the workloads, having 3 people to do the majority of the work can sometimes you get on each other's case about things. And sometimes it poses problems and we just have to work it out. So that's what we have. If you guys have any questions.
Question? I have a couple of questions. Now, when you use this in a real world setting, this battery will be, this will be plugged into the grid, or rather the house electric supply, and when it needs, it will be triggered.
Right, basically, it's plugged, the way we have it plugged, the way we have it set up is you can plug it right into where the power's coming into the house, and it can switch from utility to our power. And the batteries would basically be stored in some type of container, you know, some type of closet or something like that. But the way we have the switches set up is you put them on your utility power that you have now, and our system feeds into that power when AC is not available. So there wouldn't be any rewiring of the house except for the switching. All the
Can it
AC
also
lines.
be set up so that it can feed to the grid as they are doing in some places? Now, the thing you did with LabVIEW, all the waveforms you're showing, is that a panel that displays what is happening with this?
Yeah,
Yes.
that's actually a real time. It gives you the plots of the data that's being brought in through the transducers to the board. And it's given us the voltage and everything coming through the lines, along with the option to switch what loads you manually want to be running at that time.
And use the LabVIEW to design that?
Right.
Yes.
I might point out the chief architect of LabVIEW is one of our graduates. Okay. Thank you very much.
Mm-hmm.